All right, we are finishing up chapter 9 with 9.3. We're looking at half angle identities and double angle identities. We'll also be referencing the unit circle if you need it. And I'll be looking back and forth as we look at the work between these. In this first particular problem, given what sine of theta is, if you need to write x, that's fine. We're going to see beta and alpha as well in here. And sometimes I write that same one, and sometimes I just write x. And so there are a lot of things going on here. So as we see, like sine of theta, we see theta here is given an angle measurement, and we're looking for twice that angle measurement. So in looking back at this, so this is what we're looking at here, and we can see cosine has three different things that you can use. Right? So any of these you can use. Sometimes if you're given just sine, then we don't need to figure out anything else, and some are more appropriate than others. And then here's sine, double angle theorem here, and tangent. So this will be what we're using for those particular problems. So in moving forward with what we're given in this particular problem, what we're looking at here, we're also told that cosine of theta is greater than 0, or that it's positive. So this lets us know with x. So when we have to figure that out, we know that our final solution is going to be positive. If we're told this is negative, then after we take the square root here, this would be negative. Since we're looking at the double angle theorem for sine, which is 2 sine of theta cosine theta, we're given sine, so we can just plug that in, so 2 times this, and we're just trying to figure out what would be cosine. So that's where we use this x squared plus y squared equals r squared. So we use that information from the given of sine of theta. We use that to figure out our x. Based on that our x is positive, we then can write cosine of theta, and we simply just use that ratio here, and then we just multiply. And then in doing cosine, I chose to use this one. We can use any of the other two. I chose this one because I'm given that information. All right, so let's just say I did something wrong here. My next answer isn't dependent on that information. I can just use one piece of information. I plug that in, I square it, I multiply by 2, and then I subtract it. And that's it. In this next one, we're given tangent is equal to -3. We're told that our cosine is less than 0 or negative. So we use this given information, which we know is sine over cosine. Since I know a cosine is negative, I know that the y is positive 3 and the x is -1. So we need to find out what our r is in order to write both of these ratios for sine and cosine of x. So I do that information. There we go. And then when we sine is y over r, so when I put that over here, I have to rationalize it here. So I get 3 root 10 over 10. Same thing here. Make sure you keep that negative because we're told cosine is negative. You might be told cosine is positive, but in my case, it is negative. And so once we have both our sine and cosine, then we can just write it into whatever we're looking for. So for cosine of 2x, I'm using those same values up there, and I'm just plugging them in. I'm squaring them and then reducing it. Same over here for sine of 2x or 2 theta, just plugging in those values again and evaluating. Same thing here, we're given information about sine. That lets us know about our y and our r, and this tells us that our cosine is positive, so we need to find that x value. So this is where we're using the x squared plus y squared equals r squared again, solving for r. And since we're told it's positive, I know it's positive here, and then this is the value I'm going to be using here, the given value for sine, and then just multiply and reduce if possible. Same thing here for cosine of 2 theta, plugging in those same values, evaluating and reducing if possible. Now we're looking at the half angle. It might be helpful to look at this in case, if you want to change this to a degree, this would be 15 degrees. And then when we're looking at the actual identity, it's cosine of x. So that's what we're trying to do, is trying to evaluate. We need to find this x value or this theta or angle measurement. All right, so we're setting up the half angle x over 2 is equal to the given pi over 12. When we multiply both sides by 2, we get pi over 6 or 30 degrees. So this is what we're going to plug in here. And then this plus or minus that comes with it is determined on where and what quadrant is this. So 15 degrees is in the first quadrant, so we're going to use positive. And I'll show that later. And so we're just looking at the unit circle. What is cosine at pi over 6 or 30 degrees? It is square root of 3 over 2. And then now the rest of this problem is just simply trying to simplify that. So we get a common denominator here with 1, which is 2/2. And then instead of dividing by 2, I just put multiplying by 1/2. And then we just simplify. So we can take the square root of the top and the square root of the bottom. So that bottom is able to be reduced. The top is not. So that's where I get the 2. And then since that 15 degrees is in the first quadrant, that is positive. Same thing here, but here I included that part about changing it to a degree. It's a little bit easier to deal with. We have that 15 degrees. And then we're using, there are 3 different half angle identities for tangent. I'm choosing this one just because it has all positive things in there, and I'm a positive person. So we are looking at 30 degrees is what we're going to be putting in for this x. Since we've doubled 15, it's 30, or pi over 6. Put that in to look at my unit circle to evaluate. And then the rest of this is just simplifying this complex fraction. So this is adding a common denominator on the bottom, simplifying with the numerator by multiplying by the reciprocal. And then since I have a radical on the bottom, I need to multiply by its conjugate on the top and the bottom. And then I'm left with the solution. Half angle identity again. This one we're given degrees, so we just multiply by 2 to get 45. We're using cosine, so this is what I'm using. I know that this is positive since 22.5 degrees is in the first quadrant. What is cosine at 45 degrees? It is √2/2. And then the rest of this is just simplifying. So adding and getting common denominator at top, multiplying by 1/2 from the bottom, and then I'm able to simplify the bottom by taking the square root of 4. Here it has alpha being used here. I use x. And so we're using the same type of situation here. Here we're given this is 3/5, and we're told that we're in the quadrant 1. It's between 0 and pi over 2, or 90 degrees. So it's quadrant 1. So my x and my y are positive. So that's why I know that this is positive. Here I am told, we are told that this value is 3/5. So that means this whole thing is replaced as 3/5. And then after this is just adding and then simplifying this. So here at this last part of it, I decided not to simplify this. I decided to wait till the end. So I just multiply by rationalizing on the bottom, and then we're able to find the highest perfect square that goes into 80, which is 16. So the square root of that is 4. I can't take the square root of 5. And then I can reduce that with the 10 on the bottom. Similar type of problem here. And so since we're dealing, we're looking for tangent, we're going to need the sine and cosine. So in order to do that, I need to use my x, y, and r values. Since I have sine here is 3/5, I know my y is 3, my r is 5, and I'm looking for my x. This lets me know that we are in between pi over 2 and pi, or 90 and 180 degrees. So I'm in quadrant 2. So my x value is negative. Our y value we already know is positive. So as we solve for that x, I know when I take the square root of 16, that's going to be -4. Now I can write cosine of x as -4/5. Now I can go back and plug in these two values into this formula. Do so, and then simply simplify this complex fraction. Here we're given information about tangent of b, and we're going to be looking for the half angle. And this is beta. And just decided to use it because I don't want to be too confusing. And we're told that beta is in between 3 pi over 2, or 270, and 2 pi, or 360. So we know that it is in quadrant 4, where our x values are positive and our y values are negative. All right, so when I look at this, which consists of y over x, I know that the y is negative because I told so. So I know that the x value is positive. So we use this to find our radius. We do that and we get 3. Now we're plugging in these values here, all right? So we know our x, our y, and our r values, so we simply just put these together. Since sine is y over r, and cosine is x over r. And then I just simplify that fraction. Oops, that should be 3 right there. And then our last one here, we're given tangent of x is 2. And we're told that we are in quadrant 1 between 0 and pi over 2, or 90 degrees. So we know our x and y are positive, which means this is positive. And then we're going to need information about cosine. So we know that tangent is y over x. So we use that information to find out what is our radius, or r. And in doing so, we can now write our cosine value. So it was 1 over root 5, so I rationalized it to get root 5 over 5. Then I just simply plugged that in. Now I had to simplify. And this is something that you probably don't see much at this last step here. So we get a common denominator, we multiply by 1/2, and then we take the square root. But we're unable to get a whole number here like we did earlier, so we're going to multiply by root 10. But what makes this different is now we have a square root on top and a square root within that. So when multiplying by that square root of 10, we can multiply that times the square root of 5, which is square root of 50. But we can't multiply that by the square root of the square root of 5. So that's where this 10 goes on the outside of that root 5. Then on bottom we just have 10.